जी अस्सलाम वालेकुम. Is there any question from the previous lecture?
No, sir.
Walaikum assalam, sir. No, sir, no questions.
Okay, last time we have to discuss with myself introduction, yourself, and class rules, class materials, science, what is science, introduction to physics, why we study physics, relation with other branches. Yes.
Yes, sir.
Yes, sir.
And we also discussed about books. तो हमने बुक के बारे में डिस्कस कर लिया, पेपर पैटर्न भी देख लिया था हमने, और एसएलओ बेस्ड स्टडी भी हमने देख ली. एनी कन्फ्यूजन?
No,
No,
sir.
sir.
No,
चैप्टर
sir.
डिस्ट्रीब्यूशन भी हमने थोड़ा बहुत उसको देख लिया था, जिसमें हमारे पास ये चैप्टर्स थे. नाउ वी हैव टू स्टार्ट फ्रॉम चैप्टर नंबर 10. कोई कन्फ्यूजन है तो पूछ सकते हैं, कोई क्वेरी है आपकी?
Sir, how
Welcome,
many
sir.
total chapters are there?
यस.
Sir, how many chapters are there in total?
Approximately 9 chapters.
Sir, but it's 15, 16, and 17.
And 18. Because we are starting from the 10th chapter, and the remaining 9 chapters you have studied before in 9th class.
Oh, I get it. I get it. Okay.
Welcome, sir.
वालेकुम.
सर आपके पास अगर बुक की पीडीएफ पड़ी होगी तो प्लीज शेयर कर देंगे उसको.
जी, कल मैंने यही चीज़ एक्सप्लेन की थी कि जो पीडीएफ है वो मैंने टीम्स पे फाइल सेक्शन में अपलोड की.
ठीक है, थैंक यू सर, मैं उसको देख लेता हूँ.
वेलकम. ओके, मूविंग टुवर्ड द चैप्टर नंबर 10. Chapter number 10 is about simple harmonic motion. ठीक है. We have to start from the introduction of the chapter. What is simple harmonic motion and what is vibration and why both these are related to each other, or what is the difference between them. So starting from the simple harmonic motion. In simple harmonic motion, there is a fixed mean position. What is mean position? A mean position is the fixed point where the body can move to and fro. To and fro motion is called vibration. ठीक है, तो यहाँ पे आप देख सकते हैं in this figure there is a to and fro motion about a fixed point. ठीक है, इन सब मोशन में देखेंगे, ठीक है, पेंडुलम वाली मोशन में, दोनों पेंडुलम वाली मोशन में देयर इज़ अ फिक्स पॉइंट दैट इज़ कॉल्ड मीन पोजीशन. और जहाँ पे भी आप देखेंगे एक फिक्स पॉइंट है जिस पे वो अपनी मोशन को कंटिन्यू कर. ठीक है, तो ये बेसिकली हमारे पास मीन पोजीशन कहलाती है और इस मोशन को हम सिंपल हार्मोनिक मोशन कहते हैं. तो यहाँ पे आप देखेंगे कि हमारे पास अगर मैं कोई भी मोशन कर रहा हूँ तो हमारे पास 2 पॉइंट का होना लाजमी है और एक फिक्स पॉइंट जो कि सेंटर में. ठीक है, तो यहाँ पे इफ़ वी आर मूविंग फ्रॉम ए पॉइंट ए टूवर्ड ओ एंड ओ टू बी, बी टू ओ एंड ओ टू ए again comes to the same position, then this motion is called as a simple harmonic motion and also called as a vibration. और इसे हम वाइब्रेशन भी कहेंगे. ठीक है, कोई कंफ्यूजन?
No, sir.
No, sir.
तो अब डिफरेंस क्या है? व्हाट इज द डिफरेंस बिटवीन सिंपल हार्मोनिक मोशन एंड वाइब्रेशन? अ वाइब्रेशन इज अ वेरी फास्ट प्रोसेस. ठीक है, वाइब्रेशन एक बहुत तेज़ वाला प्रोसेस होता है. जिस तरह आप देख सकते हैं कि आपके मोबाइल फ़ोन वाइब्रेट करते हैं. ठीक है, यू कैन नोटिस इन द मोबाइल फ़ोन वाइब्रेशन देयर इज वेरी फास्ट मूविंग, बट इन सिंपल हार्मोनिक मोशन देयर इज अ स्लो मोशन. ठीक है, तो सिंपल हार्मोनिक जिस तरह ये पेंडुलम आराम आराम से मूव कर रहा है इन स्लो मोशन. ठीक है, तो ये हमारे पास सिंपल हार्मोनिक मोशन में कंसीडर किया जाता है. लेकिन जो वाइब्रेशन होती है वो एक फास्ट मूविंग प्रोसेस है. ठीक है, एनी कंफ्यूजन?
No,
सर
sir.
इसमें कोई लाइक टाइम डिफाइंड है कि इतनी फास्ट सिंपल हार्मोनिक होगी और मतलब इतनी स्लो सिंपल हार्मोनिक होगी और उससे तेज नहीं होगी, या ये बस
नहीं,
एक
एज
आर्बिट्रेरी
सच
डेफिनेशन है?
आर्बिट्रेरी डेफिनेशन है, और इसको बेसिकली हम रिलेटिव डेफिनेशन कह सकते हैं कि बेसिकली हम दो चीज़ों को कंपेयर कर रहे हैं, कंपैरिजन में आता है। अगर कंपैरिजन में देखा जाए वाइब्रेशन और सिंपल हार्मोनिक मोशन में, तो वाइब्रेशन एज कंपेयर टू सिंपल हार्मोनिक मोशन फास्ट है।
ओके सर, थैंक यू।
ठीक है, तो इसलिए हम दोनों को मतलब सेम ही तकरीबन कंसीडर करते हैं। अगर अलग अलग डील किया जाए तो यहाँ पे भी आप टॉपिक का नाम भी दे सकते हैं, ऑसिलेशन और वाइब्रेशन। एंड नहीं, एंड का मतलब दोनों अलग अलग होंगे, लेकिन और का
राइट
मतलब
सर,
दोनों सेम,
ठीक है, थैंक यू।
अप्रोक्सीमेटली हम कहते हैं सेम है, लेकिन माइन्यूट सा डिफरेंस जो मैंने बताया है वो फास्ट और स्लो का है। वाइब्रेशन फास्ट होती है, सिंपल मोशन स्लो होती है। एमसीक्यूज में अगर पूछ लिया तो ये आपको कॉन्सेप्चुअल बेस पे पता होना चाहिए।
ठीक है सर, थैंक यू।
वेलकम। तो ऑसिलेशन और वाइब्रेशन यहाँ पे जिस तरह कि मैंने बताया था कि दोनों की सेम ही डेफिनेशन है, टू एंड फ्रो मोशन, ठीक है, ऑफ अ बॉडी अबाउट अ फिक्स पॉइंट, और दैट फिक्स पॉइंट इज कॉल्ड एज अ मीन पोजीशन। ठीक है, और उसमें डिफरेंट एग्जांपल आप कोट कर सकते हो, जिस तरह आपके पास आ जाती है मीन पोजीशन ऑफ अ पेंडुलम एंड वाइब्रेशन ऑफ अ स्प्रिंग। ठीक है, एनीथिंग दैट कैन वाइब्रेट इज एन एग्जांपल ऑफ ऑसिलेशन। ठीक है, और इसमें एक फिक्स पॉइंट का होना लाजमी है। ये नहीं है कि हमारे पास यहाँ पे ए, बी और ओ पॉइंट था, जो फिक्स पॉइंट था, ए से ओ गया, ओ से बी गया और बी से आगे सी पे चला गया। ठीक है, इसको वापस हमारे पास ओ पे आना चाहिए और वापस ए पे आना चाहिए। इन दो पॉइंट्स के इर्द गिर्द घूमना चाहिए। दैट मोशन इज ऑसिलेशन। एनी कंफ्यूजन?
No.
ओके, तो यहाँ पे बेसिकली वी हैव टू डिस्कस, if we are discussing about a pendulum, then there is a rest point. That rest point is known as mean position as described in the figure. And if we are moving this mean position to some displacement that an extent, that a maximum extent, which means that it is extreme position. There is a mean position and extreme position. Extreme position is a maximum displacement or maximum distance where it can move by an external force, and we have to release it, and that ball is restored toward its mean position. वो वापस अपनी मीन पोजीशन की तरफ आ जाता है। ठीक है, और मीन पोजीशन की तरफ जब आता है उसे हम रीस्टोरिंग फोर्स कहते हैं। जब हम मूव करके लेके जा रहे हैं फ्रॉम मीन पोजीशन टूवर्ड एक्सट्रीम पोजीशन, देन वी हैव टू अप्लाई सम एक्सटर्नल फोर्स, एंड दैट फोर्स इज Newton's force, that is F is equal to ma, simple Newton force, second law. And if we are releasing from point A, then a restoring force applied on that ball to restore it toward mean position. ठीक है, and due to inertia from mean position it goes toward another extreme. Due to inertia, the property of an object that can say that if the object is moving, that tends to move, वो मूव करता रहेगा। ठीक है, और इफ द ऑब्जेक्ट इज रेस्ट देन इट टेंड्स टू रेस्ट, तो वो अगर कोई ऑब्जेक्ट रेस्ट पे है तो वो रेस्ट पे रहेगा, और अगर कोई मूव कर रहा है तो वो मूव करता रहेगा। एक रेजिस्टिव फोर्स होती है। तो यहाँ पे हम देख सकते हैं कि द ऑब्जेक्ट इज मूविंग फ्रॉम ए टू ओ, ए से ओ की तरफ मूव कर रहा था, तो ओ तक जब पहुँचा तो वो ओ से बी की तरफ भी मूव कर गया। क्यों? क्योंकि इनर्शिया की प्रॉपर्टी एग्जिस्ट करती है कि अगर कोई चीज़ ऑब्जेक्ट मोशन में है तो वो मोशन में ही रहेगा। तो वो मोशन करके अनदर एक्सट्रीम पे पहुंच गया, उस एक्सट्रीम से वापस मीन पे, फिर एक्सट्रीम पे, फिर मीन पे, फिर एक्सट्रीम पे। दिस होल मोशन इज कॉल्ड सिंपल हार्मोनिक मोशन, ऑसिलेशन एंड वाइब्रेशन। एनी कंफ्यूजन?
No, sir, no confusion.
No, sir, no
Oh,
confusion.
जी, ऑल क्लियर?
Yes, sir.
yes, sir.
सबको समझ आ रही है?
Yes, sir.
ओके, There are some terms associated with oscillation. कुछ terms हैं, कुछ definitions हैं जो कि आपको पता होने चाहिए कि oscillation में हम आगे जाके क्या क्या यूज़ करते हैं। तो यहाँ पे देखेंगे हमारे पास नंबर 1 डेफिनेशन इज़ वाइब्रेशन एंड oscillation एंड साइकिल। इन तीनों की सेम डेफिनेशन है। तो जिस तरह मैं एग्जांपल अगर वही पेंडुलम वाली ही कोट करूँ, ठीक है, जिसमें ओ पॉइंट सेंटर था, रेस्ट पॉइंट मेन पोजीशन, उसको मैंने एक्सट्रीम पोजीशन तक ट्रैवल किया, ठीक है, ए पॉइंट पहुंच गए, ए से ओ से फिर अनदर एक्सट्रीम दैट इज बी पॉइंट, ठीक है। तो अगर मैं यहाँ पे कहूँ कि वन कंप्लीट राउंड ट्रिप विच मीन दैट, जिस तरह अभी हमने स्टार्ट किया था, अगर मैं बिल्कुल स्टार्ट करता हूँ ए से स्टार्ट करके ओ तक, ओ से बी से अगेन ओ से अगेन ए तक, तो दिस इज अ कंप्लीट राउंड ट्रिप। तो एक पूरा राउंड ट्रिप जिसमें हम कहते हैं उसे हम एक साइकिल कहेंगे, ठीक है, या वाइब्रेशन कहेंगे या ऑसिलेशन कहेंगे। वन ऑसिलेशन, वन वाइब्रेशन एंड वन साइकिल। क्लियर?
Yes, sir.
Sir,
यस।
sir, can a steering wheel be oscillation? Because sir, it comes from one and it comes back to its position. Can a steering be steering wheel?
Yes, you can take as an example a steering wheel, but in detail, it is not an example of oscillation because a steering wheel is an example of couple.
Okay, sir.
And what is couple? There are two forces applied on that steering wheel. One force is upward and the one force is downward. Then the steering wheel is rotating.
Okay, sir.
Yes, and is there any confusion? कोई confusion है किसी की, पूछ सकते हैं?
Sir, if it's an incomplete circle, so it's oscillation, but if the circle is complete, then it is a rotating motion.
A circular motion or rotatory motion? Yes.
Okay, I get it. Thanks.
Welcome.
Sir,
Yes.
can we take an example of a swing?
Yes, you can take because it is look like a pendulum.
Okay, sir.
Okay, next one is a time period. Time period, which means that a complete rotation of one vibration, how much time we have to require to complete this one vibration. That is called as a time period. Which means that if we are moving from A to B, B to A, then whole time consider, okay, we have to start stopwatch and we have to note a time between A to B and B to A. That time is called as a time period. Any confusion?
No, sir.
No, sir.
The whole time that
No.
required to complete one vibration. And what is frequency? Frequency is the reciprocal of time period. If we are measuring the time and getting the time from that pendulum, that is 10 seconds, then we have to find a frequency. Then you have to take a reciprocal, which means that 1 over 10. That is the frequency. Okay? Or in other word, the frequency is the vibration or a number of cycles in 1 second. इसका मतलब क्या हुआ कि हमारे पास एक सेकंड में कितनी वाइब्रेशन, हाउ मच vibration and how much cycles in 1 second is called frequency, and it is a reciprocal of time period. Okay?
Sir, I didn't get it.
Yes, I can explain it for you like this one.
Sir,
Just please.
can you just explain that? What is the purpose of frequency? So why do we need to find out it?
The purpose of frequency is to elaborate our waveform. In waveform, we can discuss it. It is a number of vibration, a number of cycles repeating continuously and in 1 second.
Oh, I
We have
get
to
it. I get
discuss
it.
in waves, and in waves we are discussing about AC. That is alternating current.
Okay, sir. Sir, so you mean we need to find out this frequency to find out the current?
Yes.
All right.
Okay. In frequency, we can say that we are moving from A position toward B position. You can say that the whole vibration is taken some time, and that time is called time period, in which one vibration is completed. If we can say that there is 10 vibration, like this one, B, there is 10 vibration is completed in 1 second. In 1 second, there is 10 vibration, that is called frequency. Okay.
Okay, sir.
And next one is amplitude and displacement. And what is amplitude? Amplitude is the maximum displacement, which means that we are moving from mean position to extreme position, and the maximum displacement from mean position to extreme position, like O to A, is called amplitude. But what is displacement? And displacement is a point of starting toward any instant. Like this one, this point is called displacement. This middle point, or before touching to the extreme position, the point is called displacement. Any point between this amplitude we can take as a displacement. If we are considering from mean position to extreme position, then the whole maximum displacement is called amplitude. Otherwise, the displacement is present in between O to A. Yes.
Yes, sir.
Okay, sir.
Any confusion?
No, sir, no confusion.
No, sir.
In the last diagram, you can see that there is a motion Q, P, and O. And you can say that from this mean position, that is O, toward P, that extreme position, that is the distance between O to P, is called maximum displacement and called as amplitude. And in between this maximum amplitude, maximum displacement is displacement, simple displacement in between.
Sir,
Yes, please.
sir, the maximum this maximum space till point A to point B is called displacement.
It's called amplitude.
And sir, what is displacement called then?
Displacement is called as a intermediate between that maximum displacement. The distance, like you can say that if we are moving from O point to A point,
Yes, sir.
and in between you can see there, like this point is displacement, this point is a displacement, this point is at any instant.
Okay, sir.
At any instant between this maximum amplitude is called displacement. Simple displacement.
Okay, sir, got it. Thank you.
Welcome. Okay, now we're discussing about the simple harmonic motion. That is topic 10.2. What is simple harmonic motion? A simple harmonic motion, or SHM, it is also called as a SHM, is defined as a motion in which the restoring force is directly proportional to a displacement of a body from mean position. Okay, we have to move a body from mean position to extreme position. The restoring force is directly proportional to that displacement. The direction of this restoring force is always toward mean position. As I told you before, the restoring force is from extreme to mean position. Yes, जैसे मैंने बताया था ना कि एक्सट्रीम से मीन पोजीशन की तरफ जो चीज़ फोर्स है हमें अप्लाई की जा रही होती है वो रिस्टोरिंग फोर्स होती है. Yes,
Yes, sir.
that force toward the mean position is called as a restoring force. Now, here is example of bowl, and you can take as a home task, and you can perform it at home by taking a bowl, and you have to place some balls or some small circular thing at one end of the bowl, like this one. At a Q point, you have to release that, and you can check it. This ball is moving continuously between Q and P and passing through the that mean position, which means that we are taking it as a simple harmonic motion, but ideally it is in motion, continuous in motion, but physically and practically it is not possible. It become rest when it after some time it become rest. Yes.
Yes, sir.
Yes, sir.
Okay. In this whole example, you can read it and you can understand it. And after that, if you have any confusion, you can tell me. It is the same description as I told you. And at the end of this slide, there is a restoring force definition. Restoring force, it is a force that bring an object back toward mean position, is called restoring force. If we are write it in a mathematical, what is simple harmonic motion, then you can call it as F restoring is proportional to minus of x.
Okay,
Sir, it's the formula of simple harmonic motion.
It is a mathematical relation, not a formula. In formula, there is a equal sign, but there is a proportional sign. You can say it as a mathematical equation or a relation.
Okay, sir.
Sir,
Yes.
can we just call the restoring force as gravitational force?
Uh,
Because that's the one to stop it.
no, it can be anything, because the gravitational force is tends to the object to become rest.
Or isn't that
Okay.
what a restoring force is doing?
The restoring force is only doing to get its rest position, the mean position, and towards the mean position, and moving toward the mean position.
Oh, okay.
So the restoring force is a like product of gravity.
Uh, it's a sometimes you can call it a restoring force is due to uh, gravitational force. Yes, you can say that due to the weight, not it is called as a weight.
Right.
Yes. Okay, another question. In this example there is a bowl, and another example that is a pendulum. But if we are discussing about the motion of mass attached to a spring, in this motion the restoring force is due to the spring constant. Spring constant and the Hooke's law. According to Hooke's law, there is a restoring force that applied by a spring, but not due to the weight. Yes,
Yes, sir. Thank you.
it is clear.
Yes, sir. Yes, sir.
Okay. In motion of a mass attached to a spring, here you can take as another example, and we have to write its mathematical and find it is related as a simple harmonic motion. You consider there is a mass attached to a spring of m, and there is at rest at point O. If we are applied some external force to move it extreme position A, and then we have to release it, then applied a restoring force on it by a Hooke's law, that is called F is equal to minus kx. Okay. Or according to Hooke's law, the restoring force is defined as F is equal to minus kx. Minus is defined as the motion is toward the mean position. Any confusion?
But sir, how is this simple harmonic motion? Like the object will not return back to A when released.
When it is relieved from point A to, then it will restore because it is spring and restore toward mean position O and going toward another stream B, and then moving toward A O and moving toward A, again comes to A.
No, sir, but how will it come back to like I understand how it goes to B because it's being pulled by the spring, but how will it go back outwards?
Because when the spring is stretched and compressed, compression and the stretching of the spring cause this motion. Understand? If the spring is
We
compressed, then the compression of that spring will expand,
right.
and if it will expand, then the mass is also expand from B to
Oh,
A.
okay, 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 okay. Thank you, sir.
Due to the expansion. Any other confusion?
Sir,
Yes.
sir, how do you get this work?
Your voice is disturbed. What is your question?
Sir, I'm asking that how did you get this mathematically?
Yes, it is according to Hooke's law. The Hooke's law stated that if the restoring force is applied on that spring, then we have to say that according to the previous, F restoring is proportional to, that is, minus of x, and we have to replace this proportional sign to equal sign. Then we have to use some constant, and that constant is called k. Yes.
Yeah.
Noted. And that k is called as a spring constant.
Okay, sir.
And we already said that if there is mass is at rest, we have to apply some external force that is equal to, according to Newton's law, F is equal to ma. And there are two forces are acting on the same mass. If the two forces are acting on the same mass, then there is two equations. We have to combine these two equations. We get the relation is combining equation 1 and equation 2. We get like there is ma, that is minus kx. Yes.
Okay, sir.
Okay, now we have to find the acceleration. The acceleration, we have to divide that mass toward right side, that is minus kx divided by m. Now you can say that k is the constant and mass is also constant. We are not replacing another mass. That's why mass is constant, k is constant. We can replace it as a constant. Now there is a constant into x. Minus sign is for direction. Now you can say that if we are removing the equal sign with the constant, then we have a proportional sign and negative of x. And this is the final relation as described in simple harmonic motion. The acceleration is always directly proportional to displacement from mean position. It is stated at the bottom.
Sir,
Yes.
Sir, can you please tell again that where did the mass of the m, when we divided it on the other side, where did it go?
If the mass is multiply on the left hand side, then it is the mathematical relation. You have to take it on the right side by dividing.
Yes, sir, but where did the m go after you removed the
Yeah,
constant?
it will go because it is a constant. It is a constant value, and the k is also constant. Both these are constant value. We are replaced by a constant.
Oh, okay, sir. Okay.
And another step, that is last step. In that step, you can say that the equal sign and the constant is removing. That's why proportion size come, and that expression is directly proportional to minus x.
Okay, sir.
Is any confusion?
No, sir.
Anyone else?
Sir,
Yes, please.
sir, can you explain it once more? Sir, because my net was not working.
You can take video lectures, recording lectures. Yes.
Okay, sir.
Okay. Any other question? Okay, we have to stop it here. We have to take attendance. If there is any question, you can ask easily.